In this unit, we'll focus a lot on gas. Now, the gas has several subcategories, and they are properties of gas, gas laws, and ideal gas law. The purpose of this video is to focus on the properties of gas, and under the properties of gas, pressure and unit conversion of the pressure. Let's begin. Properties of gas are defined by the characteristic of the gas. And here are some characteristics. They can fill any container in uniformity. For example, here is a cylinder container containing gas molecules. So these circles are gas molecules. The gas molecules are also compressible, meaning if I were to take this a cylinder beaker and then I had some kind of top that could be compressed down, these gases could be compressed to a certain degree. They are able to mix homogeneously with other gases. So here is a blue and the orange ones. They can mix very well. And lastly, they are able to exert pressure on their surroundings. What that means is if these gas molecules are in a confined space, they're able to hit on the sides of the wall container. As shown here in the arrows, it's hitting the sides of the wall of the container. Yes, they can hit themselves as well, but the hitting of the wall of the container allows us to know what type of pressure or how much pressure is being exerted onto that particular container, hence why we can measure the pressure of gas. Pressure by definition is equal to force divided by area. So bigger the force, greater the pressure. And the smaller the area, the bigger the pressure as well. And it goes in the other way around. If you have a very small force of gas, then you would have very little pressure. If you have a very large volume of the area in which the gas exerts, the pressure is small. Let's talk about the units of pressure. Just like weight, height has units such as pounds and centimeters respectively, pressure also has their own set of unit as well. And these are some of the units that pressure carry: Pascal, standard atmospheric, ATM, and millimeters of mercury, mmHg, and torr, represented as torr. These pressure also have a unit conversion, kind of like 1 foot is equal to 12 inches. So pressure will have also, with these units, they'll have a pressure conversion. For example, here's 1 standard of atmosphere, or 1 ATM, is equal to 101,325 Pascal. 1 ATM is equal to also 760 millimeters mercury and torr. Now, this standard atmosphere, ATM, 1 ATM, what does it mean? It means the pressure at atmosphere at sea level. So I live in a sea level, not in the mountains. I actually live close to the beach, and I'm in an area where you consider to be a sea level. Way up in the mountain, the pressure diminishes. So you might be wondering, how does this pressure work? Because I'm not really feeling the pressure other than the pressure that you get from your teacher that you're about to take an exam. But you're not feeling some kind of pressure from the sky, but there is. For example, at sea level, over here, and you're standing over here, there's all these gas molecules floating in the air from where you are all the way up to the sky. And all these molecules are exerting a pressure on you. You don't come crashing down, and that's because you also exert pressure outside. Your body is designed to have the ability to carry on these pressure that is coming from outside. As you go up the mountain, the level of the pressure diminishes, and that is because there's less of the gas above you if you're out on top of the mountain. So that 1 standard atmosphere is referring to the pressure at sea level. That means we're at approximately 760 torr, 760 millimeters of mercury of pressure that we're feeling at this moment if you're at sea level. Now we can take this and do a learning check. Let's see. Pressure of gas is measured as 49 torr. Represent this pressure in both atmospheres and pascals. So let me go back. There's a look at the relationship between torr and ATM, and perhaps even torr and pascal. So let's go back real quick. So you see on the unit conversion, there's 1 ATM is equal to 760 torr, 1 ATM is equal to 101,325 Pascal. So let's target the ATM first. So we have 49 torr. And I want to convert this into ATM. We know that every 1 ATM, based on that table chart before us, is equal to 760 torr. So you're going to calculate this out. This is my calculator. And so step 49 times 1, and then divide that by 760. And I get 0.064 ATM. That's in atmospheric pressure. Now I want to go to Pascal. So I have a 49 torr, and if you look at the Pascal, we go to the slide before, and there's no relationship between torr and Pascal, but there is a relationship between ATM and Pascal. We actually know the atmospheric, and so we can convert this into Pascal. So we have 0.064 ATM, and for every 1 ATM, there's a big number, 101,325 Pascal. So this way, ATM can cancel out, and we can be left with just Pascal. So let's punch this into the calculator. We have 0.064 times 101,325. Hit enter, and then you're going to divide that by 1, which will be the same. And that's 6484. Now, it is 2 sig figs, so you just want to put the very first 2 numbers and then leave the rest with zeros without a decimal. So 6,500, sorry, Pascal. Or you can write this as in scientific notation, 6.5 times 10 to the 3 Pascal. If you were to write the top one for ATM for scientific method, it will be 6.4 times 10 to the -2 ATM.